This is problem 14. I've written a couple things up here you need to know. A joule is a Newton meter. A Newton is a kilogram meter per second squared. That will help you with figuring out your units. Since this is a wavelength of a particle kind of problem, we're going to need to use this equation. So we know what wavelength is. It's 7.75 times 10 to the negative 39th. And that's equal to Planck's constant, which is 6.63 times 10 to the negative 34th. Excuse me. And we're going to divide that by mass, which is 1,500 kilograms. And by the way, this is the unit on this, of course, is meters, and the unit on this is joule seconds. All right, so multiply or divide by the product of 1,500 kilograms times velocity. I'm trying to consolidate this and kind of move it onto one line so it's not quite so hard to read. All right. All right, I'll take time to superscript it all, and I think that'll put it all on one line. There we go. All right, to solve this equation, I'm going to talk you through it instead of doing it. You're going to multiply both sides of the equation by 1,500 V. Then we're going to divide this side by what the product is over on that side. Alternatively, you could just go ahead and, I think my first way is best. So I'll write this answer down. 7.75 times 10 to the negative 39th times 1,500 is 7.75 times 10 to the negative 39th. Don't forget to use the EE key. Have I ever mentioned that? So don't forget to use the EE key or the EXP key. Okay, multiply that by 1,500, and I get 1.16 times 10 to the negative 35th. So 1.16 times 10 to the negative 35th is equal to, multiplied by velocity, sorry, is equal to 6.63 times 10 to the negative 34th. So if I use those numbers now to solve for velocity, what would I need to do? Divide both sides by 1.16 times 10 to the negative 35th. So doing that, I get 57.1. And the unit would be meters per second. Converting that to miles per hour, incidentally, if I was a stickler for details, it would only be 57 due to sig figs. All right, got 57 meters per second. I'm going to first change to kilometers, and then I'm going to change to miles. Then I'm going to deal with seconds per hour. So I know that 1 kilometer is bigger than a meter. So a kilometer is 1,000 meters. A mile is bigger than a kilometer. You'll need to look that up, but it was 1.61 kilometers. And there are 60 minutes in an hour and 60 seconds in a minute. So there's 3,600 seconds in an hour. And then our final answer is in kilometers per hour, or excuse me, in miles per hour, it would be 57 multiplied by the things on top, which would be 1, so I won't mess with that, times 1, so I won't mess with that, times 3,600, That's 205,200. Then I'm going to divide that by the things that are on the bottom. 1,000's on the bottom. And 1.61, that's on the bottom. So I get 127 miles per hour. Or, once again, per sig figs, 130. Okay, only 5 minutes. I'll try and whip through this one. I'm going to let you guys, I'm going to work out the answer on this. And let you guys figure out the correct answer. I'll work it out. You can show the work. But the formula, since once again this is a wavelength of a particle, an electron's a particle. It's a wavelength of a particle problem. You're going to still use this equation. And in this one I gave you the relationships. The only thing that's catchy here is you need to change nanograms into kilograms. Maybe we'll run through that again for those of you who need help with that. So 9.11 times 10 to the negative 19th nanograms times. You'd put grams on the bottom, grams on top, and nanograms on the bottom, so that nanograms cancel. And then kilograms on top and grams on the bottom. Putting the numbers in, a gram is bigger than a nanogram, so that's a billion. And a kilogram is bigger than a gram. So that is 1,000 grams. So your final answer there would be negative 19th divided by 9 divided by 3. So really negative 19th divided by 10 to the negative 12, or divided by 10 to the 12th. So you're going to end up with 9.11 times 10 to the negative 31. So you can either use your knowledge of exponential notation and work that out by subtracting the exponents, or you can do it on a calculator and make sure you get the same number. And that would be, the unit there would be kilograms. Okay, final answer then. If I do I'm looking for wavelengths, so I'm going to take H. I'll talk you through it instead of writing it all down. H is 6.63 times 10 to the negative 34th. I'm going to divide that by the mass, which is 9.11 times 10 to the negative 31st. And then divide again by the speed of 2.2 times 10 to the 8th. 2 exp 8th equals. So I get 3.64 times 10 to the negative 12th. And the unit will be meters. This, of course, will be superscripted. And if you remember the dimension of an atom, it's about 10 to the negative 10th, 1 times 10 to the negative 10th meters, so 10 to the negative 12th is relevant. Compared to the atom, it's about 1/100th of the diameter of the atom. That's why we care about the wavelength of an electron and why it's possible to calculate the shapes of the orbitals that we've been looking at through the Schrodinger equation.